Hi everyone. In this presentation, we're going to be talking about specific joints and classifying them according to not only shape but also to movement. So let's get started. First, we have the atlantoaxial joint, which, like the name says, is going to involve the connection between the first two vertebrae in the neck. And this is going to be the atlas and the axis, or C1 and C2. And this joint will allow the head to be able to rotate from side to side, as we can see here on this image, such as when you're shaking your head no from side to side. And it will play a key role in the neck movement and also the stability of the neck. And this makes sense because we know that the pivot joint permits rotation only. And therefore, we can also say that this type of joint is a monoaxial joint, meaning that it only moves in one plane, therefore from side to side. Next, we have the shoulder joint, which is where the upper arm, or the humerus, will connect to the shoulder blade or the scapula. And it's a ball and socket joint, which means that the rounded end of the humerus will fit into this cup-like socket in the scapula. That's called the glenoid fossa or glenoid cavity. And this design allows for a wide range of movement in many directions, enabling you to raise your arm, rotate them, and reach overhead. Therefore, we can say that the shoulder joint will allow flexion and extension, abduction and adduction, rotation, in addition to circumduction. In addition, we can say that the shoulder joint is going to be important for several activities since it does all these movements in three directions. Therefore, it's triaxial and it will do things like throwing, lifting, and reaching. However, its flexibility makes it less stable than other joints, which can lead to some injuries. Moving down on the upper limb, we reach the elbow joint, which is going to be the connection between the upper arm or the humerus and the two bones in the forearm, which are the lateral radius and the medial ulna. And it acts like a hinge joint. Therefore, it will allow your arm to bend and straighten in only one plane. Therefore, it can cause flexion and extension. Continuing down on the upper limb, we arrive at the radial ulnar joint, which, like the name says, will involve the radius and the ulna. And this will allow for the rotation of the forearm, which lets you turn your palm up or down. And there are two radial ulnar joints, one near the elbow, which we call the proximal radial ulnar joint, and one near the wrist, which we call the distal radial ulnar joint. And together, these joints, they will permit movements like twisting your wrist or turning your doorknob, for example. And this is another example of the pivot joint. Therefore, it only moves in one axis. Moving on to the wrist joint, it will consist of two different types of joints. The one that we call the radiocarpal joint and the intercarpal joints. Now, the radiocarpal joint, like the name says, it will involve the distal articulating surface of the radius and three of the four proximal carpal bones, which are the scaphoid, the lunate, and the triquetrum. Therefore, the pisiform and the ulna will not participate of this type of joint. Now, the radiocarpal joint is going to be a condylar joint that allows for flexion and extension and abduction and adduction. Now, the intercarpal joints are going to be a plain joint that will allow the sliding and a slight twisting movement between the carpal bones. Moving even further distal, we have the carpal metacarpal joint, which is where the wrist bones or the carpal bones connect to the bones in your hand, which are the metacarpals. Now, these joints, they allow movement of the fingers and the thumb. In fact, the most notable carpal metacarpal joint is the one at the base of the thumb, which is a saddle joint. And it will involve the articulation of the trapezium with the first metacarpal. And this special joint lets your thumb move in multiple directions, helping you grip and grasp objects very easily. So overall, the carpal metacarpal joints play an important role in hand movement and function as well. All other carpal metacarpal joints are going to have a plane or gliding type of movement. Then we're going to have what we call the metacarpal phalangeal joint, which, like the name says, is going to be the connection between the long bones in your hand, or the metacarpals, and the bones in your fingers, which are the phalanges. And these joints, they allow your fingers to bend and straighten, as well as move side to side. And since it moves in two directions, this will be an ellipsoidal or condyloid joint. This means that you can do flexion and extension or abduction and adduction. Lastly, for the upper limb, we have what we call the interphalangeal joint. So like the name says, inter is between, so it's going to be joints between the phalanges. Now, most of your digits will have two different types of interphalangeal joints. The one that we call proximal, and there's another one that's called distal. So proximal is the first one, closer to the metacarpal, and the distal one is the one at the tip of your finger. Now, these joints, they act like hinges. Therefore, they only allow your fingers to bend and straighten or flex and extend. Moving down to the lower limb, we start with the hip joints, which is where the thigh bone or the femur connects to the hip bone or the pelvis. More specifically, we're going to have the head of the femur articulating with the acetabulum of the hip bone. It's going to be a ball and socket type of joint, meaning that the head of the femur fits into the acetabulum of the pelvis. And this design allows for a wide range of movement that includes bending, straightening, rotating your leg, or abduction, adduction, flexion, extension, and several types of rotation. And it's important for walking, running, and sitting, for example. And it provides stability and support for your body while allowing for flexible movement as well. The next joint moving down in the lower limb is going to be the knee joint, which is where the thigh bone or the femur meets the tibia. In addition, we have the presence of the patella, which will be located on the anterior surface of the femur. Therefore, we can say that the knee joint is composed of two different joints, the tibiofemoral joint between the femur and the tibia, and the patellofemoral joint between the patella and the femur. Additionally, we can say that the knee functions as a hinge joint, which is the same type of joint that we find on the elbow. However, the knee joint is much more complex than the elbow joint. And because it's a hinge joint, you will mainly have movement in one plane, causing flexion and extension. However, there's a small rotation that also occurs at the knee. In addition, I want you to note that the joint between the tibia and the fibula is not located within the knee capsule. So the knee capsule and its reinforcing ligaments and tendons are going to be important for limiting the motion of the knee. Lastly, we have the ankle joint, which is where the bones of your leg, which are the tibia and the fibula, will articulate to the bones of your foot, more specifically the talus. And it allows your foot to move up and down. Therefore, it is a hinge joint. We can add that the weight-bearing joint of the ankle is going to be the tibiotalar joint. So the joint between the tibia and the talus. Additionally, normal functioning of this joint, so of the tibiotalar joint, will depend on the medial and lateral stability of this joint. How will this occur? Well, there are 3 joints that provide this stability. The first one is going to be the proximal tibiofibular joint, right over here. The distal tibiofibular joint, right over here at the ankle. And the fibiotalar joint, which will prevent your ankle from moving laterally. And this completes the main joints that you need to know.